Yeah. So yeah, we're live now. So let's go ahead, and for some reason this bot keeps coming back.
Who says you're offline? Oh, now you're online.
No, it takes a second.
You want to share your screen?
Sure. Yeah, just 1 second. Share a screen. All right, cool. Let me just tell people. Cool. All right, awesome. So we are live now. I don't know how many people we have live. I unfortunately don't have a visibility into that, but probably not a lot.
Yeah, you just started.
Cool. So what are we doing today? So what we are doing is basically we're going to continue what we've done yesterday, and we are going to be building. Where is it? It's somewhere around here. Where is the car? Anyway, so we are going to build a remote controlled car with the chat. So we encountered some issues today, and Kevin, hello Kevin. First of all,
Hi.
welcome. You're going to need to raise your voice. Barely hear you.
No, it was my mic, sorry. Good night or good afternoon? I don't know.
Good afternoon here. Good night for you, right?
Yeah, I'm going to go to sleep.
So we basically had a few issues with running the Raspberry Pi today over Wi-Fi, but we eventually figured that out. And what I did was basically just reinstall the Raspberry Pi, and that's about it. So now, as you can see, nothing is connected here other than the USB power. And this is through the Wi-Fi. All right, so you can see apt-get update is working and everything is peachy.
Good. Everything's updated?
Yeah, so I did.
Can I see what the config file for the Ethernet looks like?
Well, it's
Does it
gonna
actually
show.
bring up the
It's gonna show
command?
my Wi-Fi password. So
the if
no.
config does?
Oh, the ifconfig.
Yeah.
So ifconfig is this.
So that time it does bring up
Yeah,
the WLAN.
and that's the weird thing. And just so you know, this is the same Raspberry Pi. This is not. This is the new Raspberry Pi that I kind of said, okay, let's try. But no, this is. I didn't base. This is the one that we were touching as well. So I don't know. I have literally no idea. Basically easy. We are running Raspbian Lite. So we are running a headless Raspbian. There is no graphical interface. All right, cool. So what is the plan here? The plan, if I can find it, is to basically connect this here, which is the remote control for a car, connect it to the Raspberry Pi running Node, and then basically being able to control the car from the chat. So you would do something like forward or backwards or right or left or whatever. All right. So what do we need in order for this to happen? First of all, we need a car, which we already have. And I have
so much better than mine.
Just 1 second. Dude, I literally have no idea where the car is. Like, literally, absolutely no idea. It's like, it's freaky. Do you realize the responsibility you are giving to the Twitch chat? Yeah. And when you realize it's gonna have a camera and it's gonna run inside my house, then you realize how crazy I am here.
Everyone's gonna try and knock over your stuff.
Yeah. Basically easy. Thank you for the follow. So what do we need here? So we need the Raspberry Pi. We need optocouplers. So these are these little dudes. All right. We need the breadboard. We need the Raspberry Pi. We need the RC controller. And that's about it, right?
Yeah, jumper cables.
Yes, I have. So I have these, which one side connects to the Raspberry Pi and one side connects to the breadboard. And I also have these, which basically connect to from the breadboard to the breadboard. So these are for
Awesome.
ground and all of those, right? Okay. So there are two ways that we can solve this. One is we can run the node on my computer and run Flask on the Pi.
Flask.
And basically, when something happens in the node layer, call the Raspberry Pi Flask, and then basically do the communication with Python on the Pi. And that's certainly one option. And the other option is to run everything on the Pi itself, right? So where do we want to start? Let's start with trying to do a basic communication with the remote, and not even through the chat right now. All right. So let's do this. Let me go here and do like little this. All right, cool. So now we need to install ARM node, right? So let's do Raspberry Pi install node. And it's pretty simple. It's just a couple of commands. And by the way, as a proof, I already did that yesterday on the stream. So for that, I had to have Wi-Fi, you know?
Yeah.
So let's do the full upgrade. And then I don't need the remote desktop. And I don't need to power off. Okay, there it is. So we're going to need to curl for node 8. So let's do that. Yes. By the way, the signal, the Raspberry Pi, just to follow up on our previous conversation, the signal the Raspberry Pi is getting is really strong.
So it was never the Wi-Fi.
Yeah, it was never the Wi-Fi. It was just missing the interface for some reason, which I don't know what the reason is. But that was the issue. All right, so we are at 61%. Waiting. Okay. In the meantime, what do we need? So Node, Raspberry. What are those pins called? GPIO?
GPIO out. Oh, GPIO.
Yeah, so there is this one, rpi-gpio.
Yeah, just GPIO.
And you can actually see that it supports a Raspberry Pi 3 Model B. And you only need to do like npm this. So now we're going to curl for node. All right. Come on. And then all we need is apt install Node.js. So Node on ARM is really, really cool. By the way, just so you know, you can also build Golang packages to go on ARM. So you can basically do whatever you want. And I think Golang has GPIO packages as well. Yeah, so you see Raspberry Pi for Golang. So you can do it with anything you want. You see? So that's pretty cool. I think the reason to do it with Node is really, because tmi.js and kind of the Twitch communication is really much easier with Node than with Go. Probably there's not a lot of libraries and so on that do it with Go, so it's better to do it with Node. Okay, so let's start with, while this is installing, let's start with the wiring. So you said there is, and I believe you, but I can't really see it, that there is some dot. Let's try to show it. Focus. Focus. Okay, do you see it? Come on. Come on, focus. Focus. No.
Get it, put it closer. There we go.
No, it doesn't really focus. It's almost focused, but it doesn't focus.
Dumb camera.
Oh, there it is. There it is. You see?
Yeah, make sure that's pointing to the top left on the breadboard.
Okay, so that should point to the top left on the breadboard. So how will that even really be? Okay, got it.
Useful?
So basically like this, right? Here. So this now points to the top left of the breadboard.
Yeah, and then you just put all four of them like that next to each other.
Yeah, we'll just do one.
It would be much easier wiring and organization that way.
Yeah, we'll just do one now.
Yeah.
Okay, so now let's look at the pinout for the Raspberry Pi.
Kind of have to wait for the Twitch delay to see your camera.
Oh, you. So now you can see my camera all the time. Okay.
Awesome.
Here. Okay. It's small, but you can see what basically this was what Twitch
works.
without the delay. Okay, so this is the pinout, and we basically need one of these, right? So the
For
left,
now, yeah, just one.
Yeah, so we can take that one, right? And this one should go to the top left. Basically, should go to the dot.
The anode. Mm-hmm.
All right, so this now goes to the dot. Okay. And now you want to ground it, right?
Yeah, and then the pin right under that is grounded.
And where is ground on the Pi? So the third one is ground.
Yeah, third one on the right side, or left side for you.
Okay, so it's the third top. This one. So I need to... Oh, that's not good. That's not the wire I needed. Just a second. That's the one I need. All right, so the third one. And actually, it's probably better to turn the Pi off while I do it, right?
No, not really. It's not gonna short anything out that'll break it.
All right, so now we have that one and ground.
I mean, if you want to test it really quickly, you could get an LED and put it on the right side of that. If you have anything like that, do you have a stray LED around?
Yes, I do.
Nice.
What kind of a maker would I be if I don't have an LED lying around? So I have a couple.
Nice. That is a lot.
All right. So you have to kind of post me in here, or
Don't
also
worry about the connection. Just um the short. I mean the those LEDs that you have. There's a long. Oh
yeah,
my God, the pins that come out. There's a long one and a short one, right?
yeah.
Long one is positive, so it should be pointing down. So it should be on the bottom right one.
All right.
And if you
We have an LED. Don't we need
oh,
something else too?
if you wanna manually test it to see if it works, you can insert the the orange wire into the 3.3 volt pin that's coming out of the Raspberry Pi. You have the
Yeah, one of
schematics right
these.
there.
So the bottom,
So the yellow
literally
one,
the
the
bottom one.
top left one, yeah, the bottom right one.
Nothing
Did the light
works.
turn on?
No,
Switch the light then. Still nothing.
no,
I can barely see. I need to see better.
no, nothing.
I need to see the light better. Um, do you know the number of the optocoupler?
No, I saw that's the one. Oh, it's really hot. Shit.
What was hot? The
The
optocoupler?
optocoupler.
You put it in the 3.3 volt, right?
Yeah, the 3.3.
You just broke it. You're gonna need another one.
Did I break it?
Yeah, it overheated. That's weird. The GPIOs for the Raspberry Pi are 3.3 volts.
Yeah, it's like I'm looking at the orange one here, the 3.3, and it's grounded. So again,
You're gonna need to use a new one. That one's. Can you smell a burn, or is it just?
no, it was just hot. There is
Try it
no
again.
burning. Yeah, this one is it's put aside. Um. So again, this one goes to the top left. Right. Let's just take everything out. Right.
Oh, the LED has no power.
What
The
do you mean?
LED needs its own power source. I forgot.
That's what I've been
If
asking you. I asked you if we need one of these.
what's that?
Those are like these. What are these?
No, just connect everything the way it was connected before, and I'll tell you what to do after that. I'm so
Okay.
stupid.
Okay, got it. So let's go ahead and do that. So again, I'm going to the 3.3, right?
Yeah, 3.3.
All right. This is 3.3, and this goes to the dot on the optocoupler.
Yes. So, but don't connect that part in yet. So just leave it out for now.
Done.
Then
So
connect the rest, everything else.
ground goes bottom right
Yeah.
and goes here, and then the ground on the Raspberry Pi is the third one, so it's here.
Ground goes on the bottom left.
Yeah, it's bottom left.
Bottom right. Yeah, bottom left. Ground. Bottom left.
Bottom left
You're
or
also gonna
ground.
need a ground pin, but that one's gonna go on the top right.
Okay. So this one, the bottom left, is connected to the ground, and then
Yes.
the blue one is connected to the ground on the Raspberry Pi.
Yeah.
All right. Now what?
Now, put the LED. Um, collector emitter. I'm sorry, give me a second. Emitter. Give me a second.
Sure.
Collector goes to 9 volts. So you're gonna want to put the LED top right LED, the short one.
On the top right.
Move those two wires on the right side of the board up one notch for me, real quick.
These?
Actually, move those to the right side, up one notch, and then to the right side, because that's the negative panel.
Okay, done.
And then put the LED's short pin.
Yeah.
Put the short pin in the top right, and then put the long pin into the positive on the right side. The panel where you put the where the ground wires used to be in. Put it there.
So like stretch the LED.
Yeah, yeah. So the long pin is gonna be on the right side,
Okay.
and then the short pin is gonna be connected to the optocoupler.
I don't know if that really goes that far.
I gotta watch you on the stream because I could barely see. I should be able to go that far. The LED's pretty long.
Okay. There it is.
And then on the bottom right one, get another connector.
You see?
Yeah, I see it.
Is it good?
Yeah, looking good. Bottom right one, connect that to ground.
This one is connected to ground. The bottom left one.
Yeah, but you need to connect the LED to ground. How's this gonna get its power? Do you know how an optocoupler works?
No.
Do you know what a transistor is?
Yes.
So basically, what an optocoupler is, it's like it isolates power. So there's like a little LED inside of that chip,
Okay.
and then there's a transistor right next to it. And the transistor, it's infrared activated transistor. So when that LED turns on, it activates the transistor, and it lets that other LED that you're connecting turn on.
Okay. So what do I connect now?
The bottom right one is going to go to ground.
All right. So
So
this.
get another
So
connector,
another one to
connect that.
ground because the bottom left one is going to ground as well.
Yeah, but
No, that's all right.
that's not.
Sure. Okay. This one is going to ground now too. You want to see it closer?
That's fine. I can see it. Just now connect the 3.3 volt to the to the optocoupler,
To the top
top left,
left.
and now turn on.
No.
It might be burnt.
Yeah, it's hot again.
Oh, I'm sorry. The positive, you need to connect that to 3.3 volts too. Sorry. It might be that the optocoupler is broken, so just try to use another one.
No, that's
But
another. That's a new one.
okay.
That's not the previous one.
I'm sorry. I'm looking at your stream. It's a little confusing.
Okay. So let's go. Let's go.
You you
Let's go
reconnect
back.
everything the way it was.
Okay. So let's go back. This is on the top left, going to the 3.3.
Yeah, disconnect that for now. So it's
Okay.
and
So
then bottom left is ground.
bottom left is going to ground. All right. Bottom right is also going to ground.
Yes, sir. And
Okay.
then connect 3.3 volts to the line on the right side, so the LED can get some power.
All right. So now we have 3.3 to the LED. And now we need 3.3 here as well. To the
Yeah. So
top left of the optocoupler.
yeah,
All right. Let's give it some power.
you
I
need
need.
another connector.
Yeah, I need another connector. There it is. Okay. So where is another
And find another.
3.3?
You gotta look that. There's another one right below right above the first one.
No, that's 5 volts.
No. Well, oh, I'm sorry. I thought I was looking at the red.
There's
There's one all
only
the way down there.
two.
See it? You see it all the way down there? It's next to 22 and
Yeah,
10.
yeah, I see. Now I need to count it. So this is like 1, 2, 3, 4, 5, 6, 7, 8. That's the ninth pin, right?
Yep. Yeah, I counted 9 too.
All right. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the one. All right. So
You're gonna have to count it again now.
yeah, now I need to count again. 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's the ninth. And this goes to the top left.
Yeah, no. There we go. See?
Dang.
Working. Now
We
disconnect it before again.
we connected a leg. That guy's
Yeah. But
confused.
when it comes to the button, it's gonna be much simpler because the LED doesn't need a positive and a negative. It's just gonna be a button.
So wait, if the optocoupler is getting so hot on a simple LED,
Opto. Probably just gonna have to use a resistor then. Optocoupler operating.
so Pepe newbie, who do you mean is confused? Is it me confused? I am confused. I am out of my league here. All right, so we are now in business, okay? So what we want to do now is connect it to the remote control, right?
Yeah. Give me a second. Yeah, you're probably just gonna need a resistor. Do you have any resistors?
No, I don't think I do.
Or I mean, you could do it for now, with the 3.3 volts, but you don't want to leave it on running like that for a long time because obviously it'll burn out the IC. So whenever you have time, just order some resistors, some 10K resistors. Just look those up on Amazon, and we'll wire it up when we get to it.
Let's see.
Probably gonna have to like buy a pack of different ones. Or
Oh,
not.
I
Okay.
do have those lying around. I'm sorry. Yeah, I have those lying around. The brown, black, orange. I do have.
Brown, black, orange, gold.
Brown, black, orange, gold. Yes, I do have those. Somewhere. Somewhere. But yes. Anyway,
Yeah, but
so
no, you can do that. Shouldn't be a problem if you use it for too long. You're just testing it, and they're not constantly gonna be on all the time. It's just gonna be a button press, you know.
okay. So now let's go ahead and connect this using the Pi, using Node. So in order to do that with Node, so what we want is basically to light up that LED with Node, right? So all I need is to change the circuit and connect it to the GPIO, right? And then I can
Yeah.
light up.
The only one you have to change is the top left one. That's it. Everything else stays the same.
No, I mean the one that's connected to the Pi. That's the one that needs to change, because
Yep.
instead of
Only
going
that
to the constant 3 volt, it now needs to go to the GPIO.
GPIO.
All right.
Yeah, that's it.
Cool. So let's go ahead and go back to that. All right. So the LED short goes to the top right.
Excuse me? I didn't hear you.
The LED short leg goes to the top right.
Yep.
Cool. The top left goes to the 3.3. The bottom right goes to ground.
Yep.
Bottom left also goes to ground.
Yep.
Cool. We are getting somewhere. Where is that? Where is that? There it is. All right. Bottom left also goes to ground. Cool. And then we need the ground pin on the Pi, which is the third one. So this one goes to ground. And then the ninth one goes to the 3 volt. Wait, so the ninth one still goes to the 3 volt?
The ninth? What do you mean? Ninth?
So we now need one 3 volt and one GPIO?
Yeah, the 3 volt to power the LED, but you can just put the ground and the 3 volt, 3.3 volt on the breadboard's right side.
Yeah.
And not worry about it ever.
No, but what I want is to programmatically turn on the LED.
Oh yeah, that one goes to the GPIO pin. That goes the top left one. I think it's the white one if I'm looking at it closely.
No, it's not connected. This is the bottom left one.
Oh yeah, the top left one. That's the one that's going to be connected into the GPIO.
top left one, that goes to GPIO, which is
The two pins on the left are just basically turning on an LED. But the only thing is that the LED is inside of the chip and you won't see it.
yeah. And now this one goes to a 3-volt from the top right.
For the LED?
Yeah.
The LED,
So this one, like here, goes to 3-volt.
yeah, the LEDs get you connect that to 3.3 volts. Number 9.
Right, but now it's on.
It's on because you have it connected to. Take it out real quick. Take out the top left one. I mean, connect that back and take out the top left one. Is that the one you just disconnected?
The top left one, yeah.
Okay, then it's working. Did you connect the top left one to 3.3 volts or to GPIO?
No, to GPIO.
All right, then that means the GPIO is constantly on. You're probably gonna have to switch it off through Node.
Oh, you think it's constantly on?
Yeah.
All right, let's turn it off.
That's the same way with the ESP8266. So if it's not activated, it's constantly on.
Okay.
I just do it all over myself. Okay.
So SSH, let's SSH to the Pi again. Now where's the Pi? Is the Pi dead? No, the Raspberry Pi is on. So why can't I SSH into it?
Wasn't it still downloading all that stuff?
No. No, it's like the SSH session is not responding.
Restart the Pi.
Mm-hmm. Okay, so we are restarting the Pi. Cool. In the meantime, let's look at the code we need. So we need to do this, npm install rpi-gpio. And then the code we need is really simple. Basically this. GPIO setup, and then where is the high one? So gpio.write 7 false. So the write has, let's see, it has a channel and a value. Writes the value to the channel, references the pin, value, Boolean value to specify whether the channel will turn on or off. Okay, cool. So basically what we need is just this. So let's do vi test.js. What happened? Something died. That's not what I wanted. Okay, so this one and then here. This is what I want. And this is pin number 2. Right? So this is going to be pin number 2.
It's going to turn on and turn off extremely quickly. Give it a small delay.
So here we're going to do like what? Sleep. How do we sleep here?
I don't know.
Yeah, this is the delay. The set timeout here.
There you go. Set timeout. Delay.
Yeah, this one. So we can do that. And then GPIO.write pin 1 and then what? What is off? Function off. Oh, so got it. So this basically turns it off.
On and off, yeah. On and then it gives a delay and then off. So you just probably have to copy that whole entire thing.
Yeah, I don't know if we really need that.
I think that's the only way to give it a delay with JavaScript, to be honest.
Yeah, that's with JavaScript. That's the only way. So function on count is max, and then yeah, let's do that. And pin for us is number 2, right?
I don't know which one you're using. Make sure. There we go.
All right, so we need to do npm install rpi-gpio.
It's about another 20 minutes right there.
That's true. Sad and true at the same time.
It's a Raspberry Pi.
It's like I remember I remember 1 gig of memory. You know what I mean? Like I remember having a computer with
Oh no, I'm not that. I'm not old.
dude, don't. Okay, so then this one is set paste and here. All right, so pin, we are connecting this to pin number 2. Let's look at the pin out. Where is the pin out? We had the pin out here, right? So we are connecting this to pin number 2. So we're saying pin number 2 delay, right? That's it. So we're gonna connect that to pin number 2, and then run node app.js, and nothing really happens.
Did it run it?
Well, it's running it, but it's not really doing anything.
That took an awful long time.
Closed pins, now exit. What? All right, so pin is number 2.
Is that delay in milliseconds?
Yeah, it's 2 seconds. Well,
you have to open the on the page. The first thing that says is you have to open the port for output. You need to open that GPIO to allow output. Look at the GitHub.
okay.
Scroll all the way up. Go down, down, down.
Dependency usage.
What the hell?
Oh, this one, like setup?
No.
I have that. Setup and write to a pin.
At the very top of the page, and then scroll down. It's like it's not the same for you and me.
I'm looking at this one. I pasted it in the Twitch chat. Usage. Firstly, make sure you're running your application as root or with sudo. Else the Raspberry Pi will not let you output. Oh, that's good. Okay. So sudo node. So let's connect this to the output and then app.js. So I'm seeing the same thing, which is not.
Oh. Okay. Huh. They're so similar.
So it's telling me close pins.
I was looking at wrong GitHub page.
Okay.
If you look at the one that I posted in the Twitch chat, that one looks like it makes more sense.
Okay.
See?
This one? Okay, so now npm install is done. And now
That first code right there that says gpio.open 16 output function error.
This one, 16 output.
Yeah. So just set that to 2.
Okay. And then write and 1 is high and gpio.close. Okay. Okay, so this is now this one.
Set it to 2.
Yeah. Okay, so that's 2.
That was cool.
And then sudo node.
Spell it right.
Yeah, I know. So sudo node app.js. Throw new error. Pin number isn't valid. So that's basically the same thing that happened with the one before. And I'm looking at the Raspberry Pi pinout. And it's pin number 2, 100%.
RaspberryPi pin out. Give me a second. Connect it to 17 or 18, just in case it probably, just in case. Maybe that'll fix it.
Oh, now I need to count again. Okay, so 1, 2, 3, 4, 5, 6. Oh, wait, now it's off. That's odd.
Which one do you have it on?
No, but it's still giving me pin number isn't valid.
All right, give me a second.
So ground is connected. And everything seems to be connected correctly. Okay, so this is 1, 2, 3, 4, 5, 6, 7. So now it's on pin 27. Is it something that I need to open GPIO in Raspberry config?
Which Raspberry Pi do you have? 3?
3, model B. Interfacing. Serial enables serial remote GPIO. Enable disable remote access to GPIO pins. Well, I don't know what that means.
That's weird.
Failed to restart. No such file. Unit GPIO-D service. What? So yes, they are different from Pi 3 and 2. Oh, this is stupid.
What?
No, I'm stupid.
Is it the wrong one?
GPIO. Raspberry Pi. Okay. So it's pin number 3.
Yeah.
No, but this doesn't make sense. But okay, let me try.
God, I love that.
All right, so this is 3. Great. GPIO.close 3. Awesome. So now let's do sudo node app.js. And GPIO admin not found. What? GPIO admin implements blah, blah, blah. What are we talking about? Which? Let's
You see the
turn
fix
this
there? It said change the var of GPIO admin equals instead of in the GitHub.
Yeah, but I don't see a which for this. You see, it's like it's not existent. It's non-existent. GPIO admin Raspberry Pi. Quick to wire. What?
You have to install something else?
Really? Use the GPIO pin on the Raspberry Pi without running as root. But I am running as root. Which GPIO admin? So no, it's like it doesn't exist.
What's the difference between sudo and root?
Make, yeah, I'm gonna run make, sure. What? GPIO admin missing. Okay, so this one is Node.
Looks like it's a node error, not just.
Well, but what I'm saying is I don't see any GPIO admin at all. It's like command not found on the Raspberry Pi, regardless of apt update. And then what is this? This is Node. But I have this one.
I mean, you could try running, installing the GPIO admin on GitHub from GitHub. See if that fixes it at all.
GPIO admin GitHub.
Yeah.
You mean this one?
Yeah.
This the quick to wire one?
Yeah, the one that said without root. Just in case.
This code is no longer necessary.
That's great.
Okay, Raspberry Pi, GPIO 0, friendly Python API for physical computing. What are we talking about? Sudo node app. Yeah, it just doesn't found the GPIO admin. Well, this is very weird.
Raspberry Pi is annoying. Let's switch over to the ESP. Believe me, it'll be so much simpler. Except for the fact that you won't be able to use the GPS and stuff. You're gonna use up all the memory so quickly.
Yeah, exactly. You also need to install GPIO admin. Oh, I don't have Git. This is.
I think it might be because that API was for Raspberry Pi 2. One of the guys in the Twitch comments said that.
Yeah, but he said that on the pin numbers.
He said functions, not pins.
Yeah, but he said that on the. All right, now we have GPIO admin.
That's great.
All right, so sudo node app.js failed to change ownership.
This gets harder and harder, doesn't it?
Shit, it does. Sudo node app.js failed to change ownership of this one, No such file or directory. Great.
I think the program runs. It just gives you that code anyways.
Usage, GPIO pin, pull up, pull down. So let's, what is the pin? 3?
Yeah, and then pull up.
Pull up. GPIO admin.
Brackets.
Export. No, okay. So fail to change ownership. Great. No such file or directory. Oh man. I I really don't get it though, I have to say. It seems weird, doesn't it?
Yeah. I've never messed with the Raspberry, so this is all new to me.
Well, it's all new to me too.
Oh, we're learning though. Say that.
We are. Headline device tree equals in boot config. That will revert the links to be the old path. Make sure you reboot.
You try using rpi.gpio dash gpio again. You already have it installed on the.
You mean the previous one?
Yeah. Try. You go to the examples page and go to the first one that says set up and read the and write to a pin. Yeah, it wasn't that big.
Yeah, it was.
There's just this here.
This one with pin 3.
Skype chat. It's on the Skype chat.
Where is it? All right, this one. Okay, so what pin number are we on again? Pin number 3. All right, so now it's on. And let's go to this and change 7 to 3. And sudo node app.js. And I think it's going to do the same. Oh, did you see that?
It just worked.
Written.
Yeah, it worked. Turn it on again.
Written to pin.
Is it still running? Don't tell me it's still running.
Yeah, I think it's
It's
GPIO.write, and then let's do false here. Dang.
want to change that back to true. That doesn't do anything.
Well, it's off.
Oh, okay. Yeah. On or off.
So the false here.
Means on or off, right?
Yeah. And this blocks. So that's interesting. So this one actually blocks, which is weird, but it blocks.
That's not the one.
So right, we have a channel value and a callback. The callback provides error as the first argument if an error occurred. So the question is, how do we turn it off again?
Wasn't that setting it to off?
Oh,
I mean, setting it to false. I mean.
Yeah, but what I'm saying is this code blocks.
I don't know what that means.
Oh, I get it. So basically here, if we do this.
I still don't understand how you're supposed to give it a delay, to be honest.
So sudo node app.js. So yeah, you see this? So this, yeah, got it. It blinked. I don't know if you saw that.
Try run it again, please.
What happened now? You see? It's like,
Why does it take so long?
I don't know. Something is blocking. Yeah, do you see that? Now it kind of blinked and that's it.
It ran it fast and then it ran it really slow.
Yeah. And
Debug it? Can't you debug it?
and the fact that the code blocks is the most is the most confusing part for me, because why would this code block? So console.log, and then let's do here. Let's do console.log done. So why would this function not exit? Do you know what I mean?
You're gonna put that console.log on every line, on every function.
We already have one. Yeah, you see, done is. Oh, I see what is going on here. It was a race condition.
Oh, it's. Does that mean it's like they're running asynchronously, right? No, no, I was wrong.
No, they're not running asynchronously, um, but they are blocking, and they could have a race condition. Okay, so we have done the basic. So we have everything kind of ready. All right. So now, what do we need to wire in order to run the car?
Disconnect the USB and connect it to one. You found the car.
Wait, the car is moving now. Just a sec. Oh, there it is. I found it. Just a sec. There it is. Bam. Bam. All right. So, okay. Cool. So, now the car is on the floor, and let's connect to the car. So what do we need now to switch this to the car?
Just take out the LED and get two jumper cables and just connect them to the buttons.
All right, so the LED is out. Okay. And now we need. All right, guys, are you ready? Are you gonna control it from the chat any time now? Any minute now. All right. Let's look how many cables I have. So we need two here. And we need to connect it to the bottoms, right?
Yeah, to the buttons. But you're probably gonna have to solder for that, unless there's like a way that you can just nudge them in there. That's the way I did it.
Yeah, I can nudge them in there. So where does this connect to? Just any part of the button?
There's 4 pins, right, or are there 2?
There are four. 4 pins.
Can you hold up the back of the board to the camera and give it a small delay while I look at it on Twitch?
So just so you'll understand, this is the button. This is one button. Here. 1, 2, 3, 4.
So hold up the button side of that up to the camera really close. The other side. I'm sorry. The other side. The button side is what I'm saying. I'm sorry. Other side. I'm sorry. The green side is what I'm saying.
Yeah, that's up.
Yeah. And hold it really close to the camera so it can focus.
All right.
I need to see which part of the connection is the button on. God damn it, camera.
Come on, focus! Focus, you damn thing.
Just hold it still and hold it up to the camera.
I'm trying. It's not as easy as it looks.
I know, I'm sorry. Alright, there you go, I focused. That's the button, right? The top right?
Top. Yeah.
Alright, give me a second.
All right. In the meantime, people in the chat room people, time for questions. I don't know how many viewers we have. Probably like
13.
2. Really, 2?
No, that's a 13.
Oh, 13. So this is a left turn, just so we'll understand. So does it?
All right.
Yeah.
Oh, it's gonna be kind of hard to explain this. Oh. The fuck? Playing around with it. Let me see the board again. So can you show me the green side of
Yeah. So this is the button here.
the green side of the forward button?
Come on,
That's the
focus.
forward button. Is that the forward button?
No, that's the left button.
Show me the forward one, because I want that to be the first command.
No, I don't.
Why not?
So this is the forward one. This one.
All right. Which one do you want it to be?
Let's do the forward one. That's okay.
So those 4 pins right there are the forward one, right? Oh, there we go. So based on my view, the 2 pins on the pin on the top and the pin on the bottom are the ones that you should be connecting the jumpers to. So on the left side,
Here.
the ones on the left, I think it's the right for you. Yeah, the right for you. For you, it's the right.
This one.
So the pins, yeah. Those that pin and then the bottom pin, the pin under that one is what you should be connecting
So
the
this one and then that one.
yeah, and the one right under it. So try to nudge
So for me, so just so we'll clarify, for you is the one on. So
the left,
shit.
and for you it's your right.
This one
Yeah, those, and then the one right below that.
and that one.
Yeah. So you not
So the
solder.
internal ones, basically.
Yes.
Okay. I am connecting.
Try nudging those jumper wires in there, and once you do, just short those wires out. And if the car goes forward, then it means it worked. And if it doesn't, then just play around with it. Just connect different ones together and see which ones work. Because I can't really tell you exactly from all the way down here in East Coast.
Right. So that's I think we're gonna need to solder this. I don't see any way to really.
There should be the little pin right under it. You should be like to nudge it in there. No.
No, it's they did too good of a job. I can't
All right.
do
Well,
it on.
just first try shorting them out with a piece of metal or something. Shorting them out should activate the button. That's how buttons work. So just turn the board upside down and then just get one jumper cable and just press them. Put one on one side of the.
Yeah. So if I shorten these.
It's those two.
Yeah.
Okay, so just mark it or remember it or something. So when you're soldering, you can remember that it's those two.
So yeah, it's those two. If I shorten them, then the car moves.
Okay, good.
You hear that?
Yeah, I hear it.
And it's the same thing here. And here. And probably here.
It's probably the other ones then.
No, here. All right, so it's the bottom ones here, and the
Get a
right
marker and
ones,
mark it on the orange part so you can remember.
and the right ones here. All right. Cool. So, are we really gonna solder these on the
I mean, if you can't, if there's no other way, then yeah.
viewers? 14.
You could finish. You could finish writing the Raspberry Pi code. Make sure all that works. Hook up all the opto oscillators.
No, I just want to see one, and then we can wrap it
Okay.
with. And then we can. By the way, if it's too late for you.
Yeah, I gotta go to sleep soon.
Yeah. So we only need. So for the rest of them, we only need one 3-volt wire, right? The same 3-volt wire can power all of them. Okay, yeah, I got it. I got it.
You don't need 3 volts to power the buttons.
No, dude, I got it.
Oh, the button. Oh, you mean the GPIOs?
Yeah. I got it. All right. So, yeah, we need to solder this. For that, I need to disconnect my soldering iron. Well, to connect it, not to disconnect it, obviously.
All right. Well, I'm gonna go to sleep.
All right,
Got work
man.
tomorrow.
So thank you, and we will talk tomorrow.
All right. Good luck. Good night.
Good night. Bye-bye. All right, now I'm alone. All right, so what we're going to do now is I'm going to try and play around with this for just another second to see if I can really kind of wedge that in. It almost seems like I should be able to, but it's just not enough. So if I had a thinner cable, like a thinner connection, then I might be able to, but it seems that they all are just not enough. Hello, Stevens. How are you?
How are you, Avi?
I'm doing well. How are you?
Can you hear me?
Say hello to everybody. It's like I've been streaming for over an hour.
What's up, guys? Oh, you already started? Like an hour ago?
Yeah.
Oh, all right.
Now you can see my screen?
Yeah.
All right, cool. So you see this all connected here?
Oh, that's cool.
So now, the car is dying. All right, cool. So what I'm going to do now is I'm going to grab the soldering iron and start to solder this for a second, okay?
All right.
So people on the chat room, bear with me for a minute. I'm going to grab a soldering iron. Ta-da! Soldering iron. Ta-da! All right. So this is going to go here, and this is going to go next to it. And now I need to go under my desk to connect this. Stevens, say hello in the meantime.
I already said hello.
Yeah, give people a chance to ask you some questions or something.
All right, everybody. Anybody got questions for me? Going once? Going twice? Done.
They're like, fuck off, man. Who are you?
Yeah, I'm Stevens.
All right. So now the soldering iron is connected, and it's getting warm. So we're going to solder a couple of these in a minute, and then we can control the car from the node side.
What are you soldering again? Like this is that's a Raspberry Pi, right? On the
yeah,
right
I'm
side?
soldering the remote control.
Mm-hmm. To the Raspberry Pi?
To the all right. So these are the button ones. All right, cool. Cool. So what I need is to solder this. You see this?
Mm-hmm.
Onto here.
What is that chip? The smaller one?
That is the remote control.
Okay.
All right. Cool. So is this warm enough now? Yep. All right. So I'm going to solder this. Now I need 3 hands to do this, and I don't have 3 hands. Ah! Okay. So now the other one. Okay. All right. So we are golden. And now what we need is to turn this on. So it's this one here. And then sudo node app.js. Oh! Oh!
Whoa!
All right.
Wait, so how are you sending the signal to the remote?
Wait a second. What? So yeah, it's working.
Do you mind explaining like just the higher level? How are you sending the signal?
All right. So just 1 second. Before we do that, let's do sudo so vi app.js, and then here we'll do a false because I want to turn this off. We just controlled a remote a car from Node, so that's pretty cool. Right, and now this is off. Okay. Awesome. So now what I want is, let's say this. Okay, so let's do something else. So let's say function. Oh, this is annoying. Function on, like so. And what this is going to do, this is going to be doing that, right? And then here we're going to call on. And here we're going to have a function called off. And in this function, what we're going to do, so this is going to be true. And then here we are going to do set. This is annoying. Set timeout. And we are going to say, set timeout JavaScript. Set timeout, so we have the function. Great, so then we're gonna call off in 1 second. Okay? All right, so sudo node app.js. Oh, wow. The car moved for a second and then stopped. Let me try. How can I do that? How can I do that? Oh, I can actually do that. Right. So let's do that. Just 1 second. All right. So here. Can you see this?
Yeah.
All right.
Wow.
So this is pretty awesome.
Explain how it works, man.
All right. So people in the chat room, why are you so quiet?
Because you didn't explain how it works.
No. Well, no, it's
You
not.
gotta
Because,
demystify.
no, something is happening.
What do you mean something is happening?
I don't know. People got dropped. It's like we had 14, now we have 10. So I'm boring someone.
Yes.
Hmm.
You should explain.
All right. So here's I will explain. Okay. So let's do vi app.js here. Cool. So you see this circuit, the Raspberry Pi circuit. Let me move here.
Are you pointing to somewhere?
Oh man, you're such a. All right. Cool. So here. So here. We have an electric circuit here. Okay.
The white one, the middle. Yeah. Okay.
Yeah, it's like everything here is an electrical circuit together.
Okay.
Okay, so we have this thing. It's called an optocoupler, and it's just basically a way to get consistent current from one place to another.
All right.
And then we have this one. You see the orange one?
Yep.
Is connected to a signal on the Raspberry Pi. So you see this
signal.
Yeah, it's connected to a pin on the Raspberry Pi that is sending out messages, right? So the messages are basically two messages, either high or low, on, off, true, false, right? All of these are basically the same thing.
It's a binary message, basically.
Yeah. And then what happens is that when I write to this channel, basically to this wire, it passes current into the circuit here, and when that happens, then it shortens the circuit here.
So the little chip is the chip for the remote control.
Right. So this is let's do a introductory here. This is a remote control. This is a breadboard.
Yeah.
And this is the Raspberry Pi. This is me.
Okay. Got it.
This is
the bread
a computer.
All right.
So the breadboard is just a way to connect things without wiring them together. Okay, so the whole thing that this is just a way to not connect things into each other. That's it.
So it just transmits the signal. It just conducts the signal.
Yeah,
basically.
That's it. It just conducts the signal. So on the breadboard, all of the vertical dots are connected to each other. And this is a short. So basically when you have this is a divider. So all of these are connected to each other, but they're disconnected from these. And these are connected to each other. And now we have the plus and the minus here on the bottom right. And these are connected horizontally. So all this row, right? So if we look at this is a column and this is a row. So here the columns are connected together and here the rows are connected together.
All right. And this is called a what again? This is called
This is a breadboard.
Breadboard. Okay.
My daughter calls it a matzah board.
A matzah board. Okay, the breadboard. All right. So, but how can you I think the most mysterious thing is how did you convert how can you make it do such complex things with just an on and off signal? You're doing something like timeout, or you're doing like on off.
All I'm doing here. So the heart of it is this. So write to the GPIO. GPIO is that thing, right? So all I'm saying is write to that GPIO. And then once you do, then everything happens. And then after a second, write false, right? So basically turn it off. So what happens when I run this is the car runs for a second and stops.
Oh, so it sends a signal for like 1 second and then just cut off the signal.
Yeah.
Something like that.
Yeah.
The GPIO, is that like a sort of library for that thing on the Raspberry Pi? Like that's the adapter?
Yeah, it's a library for the Raspberry Pi. And we had a few issues. By the way, Kevin Jarmahent helped me a lot here for the first hour of the stream. So kudos to him. He helped a lot with connecting and everything.
Jarmahent.
All right, so now what we're going to do, we're going to run this through the chat. So who wants to be the first one? So tmi.js npm. So tmi.js is a library for Twitch. In the bum, no harm done. You are the one. No problem at all. So let's go ahead and install tmi.js here. Okay, tmi.js. This is what I want. And then let's do examples. And then, no, I want chats. Chat, receive messages. Okay, so client on chat, and then we have the channel and we have the message. Now for the client, we actually need to init the client. So let's go ahead and do that first. And I think I have. So what I need to do it, I'm doing it off the screen, is I am generating what did I want to say? Oh, I'm generating a token. So let's go ahead and generate a token first. So let's go here, configuration. Great. So configuration client ID used to identify an application here. And here we have like these. So what I need to do is I need to basically connect with my bot account and then create that application. So I'm going to do that off the screen. Okay?
Cool.
And I'm going to connect with my bot account.
Oh, Jeff is going to... Oof.
Okay, so logging in. Oh, man, come on. Stop this. Twitch is forcing me to...
Stop it.
Fullstack bot and all right, so I forgot the password for my bot, so I'm going to reset the password.
Hey, can I ask you another question?
Yeah.
Where is the electricity coming from for the remote control board? I don't see a battery there at all.
Well,
like the smaller chip, does it have it?
It's like there is.
Oh, so that's the battery. Oh, there is a battery.
Yeah.
I see. And you solder the wire onto the remote control board, right? That's when you were doing the soldering?
Yeah.
All right. It's pretty cool.
Okay, so I have the login here. Okay. Great. So I have what I need. So what I'm going to do is I'm going to SSH to the Raspberry Pi, again, off the screen, and put a file there with what I need. Okay. Okay. So I'm going to copy the auth credentials. All right, cool. So now I'm going to source credentials here. Great. And now I have my auth. So let's go and add tmi.js here. So let me check that. Just 1 second. Great. So now let's start client.js here. And we are going to say that auth. So let's do var auth equals to OAuth. And then this plus what's process.env name node. I think it's process.env.name. So process.env.something. Great. So this is process.env.auth. Okay. So var username is going to be Fullstack bot. Okay. And then what we need is to create a new client. And I'm basically copying from the documentation. Okay, so let me do that. And username is going to be username, and password is going to be auth. And channels is going to be kensodev. Okay. And then we're going to start a new client.
Did you install Vim on the Raspberry Pi?
It had VI, not Vim.
This is VI.
Yeah. And here we're going to do console.log message. And let's do console.log user state. Okay, and then sudo, no, we need just node, what did we call this? Client.js. Missing, okay, so vi client.js. What are we missing? Console.log here. Oh, okay, got it. So this is the function, and then we need to close this. Okay, so node client.js. TMI not defined. Oh, we need to require TMI, yeah. Okay, so vi client.js, and let's include TMI here. Node login authentication failed. That's weird. Okay, so let's do this. Okay. All right. So what I'm going to do is I'm just going to regenerate the auth.
Okay.
Sorry.
So let's go to Twitch apps, chat token. And I think, let's go here, settings, and where is it? Like connections. Twitch chat OAuth token generator. There it is. So Twitch apps. People are really quiet in the chat room today. All right, so let's do this. Oh, let me do that off the screen, actually. So let me do that here. So here, let's do source credentials and node client.js. So yeah, login just fails. And let's copy this here. Okay, and now source this. And actually, let me do something else. All right, so let's do export auth equals to cat credentials. Okay. So again, export auth equals to cat credentials. And let's go to chat. Where is this? Oh, it's client, vi client.js. And then this is going to be process.env.auth. Okay?
All right.
And the username is going to be Fullstack bot. All right, so node connected. Great. So
Whoa,
now
look at that.
we are live. And let's do test. Great. So I see the message is test, and the display name is KensoDev. So in the barm, in the bun, no harm done. Are you here? So who is here and wants to control the car first?
Yeah, guys. If you don't go, then
All right, there you go. There you go. All right, so let's do that. So you are going to be the only one allowed. So let's go here to client.js and say that if user state dot, what was it? Display name. That's not good. I want something else. This one, username. Here. Okay, so this dot username equals to this. Right? So then we are going to say if message equals to forward, okay? So then let's save this and go to our app.js and copy this.
Wow, this is actually gonna work. This is actually gonna work.
Okay, so now are you ready? vi client.js, and then let's put that here. And put that here.
Damn, I'm so excited
And
to
then
see
here,
this.
this is going to be on. All right, go ahead in the bun. No harm done. Wait. Before we do that, wait. Wait. So something here. Just 1 second. Vi client.js gpio.setup, and then let's do on. gpio.setup. What is gpio.setup? gpio.setup node. Kamzak, you are going to also do that soon. So let me look for that. Just 1 second, because I want to see what this setup is. Something is not clear to me on what this setup is. So let me check. So setup. No, that's not what I want. Setup channel for read or write must be done before the channel can be used. Well, I don't want the function. So let's try that without the function. All right, so let's do that and node client.js. All right, so in the bun, write forward, all caps in the chat room.
Whoa, look at that. It's working.
Go ahead, go.
Go one more time.
Go. Don't be shy.
Just keep spamming it, man.
No, he's a good boy.
Just keep spamming forward like this.
Oh, you can't do that. Your message
no,
was
I
not
can't.
sent. Oh!
I cannot see it.
No, it's locked. It's locked for
Yeah, it's locked 30 seconds.
It's
Like-
locked. Wait, who
No, that was him. That was him. That's not me.
Ow! Just a second. Oh man, just a second.
Wow.
Just a second. All right, I'm putting it on the floor. You guys can go ahead. In the bun, it's only you, by the way.
No, it's only in the bun right now.
All right, so.
All right, take turn. Let's take turn.
Oh man, that's crazy. Look at that, how insane that is. All right, so what we are going to do now is implement backwards. Okay, And Camzak, do you want to give it a shot? So I'm turning the car off for a second. And I'm going to stop the chat bot. All right, so then let's do here console.log message. And then here, oh man, this is annoying. This is VI. And then console.log user state.username, because I'm going to whitelist someone else, and Camzak is the one. All right, so node. All right, so Camzak, write something in the chat. Doesn't matter what, just write something, because I want to see what your username is. So go ahead and write something. Come on, man, write something. All right, Camzak is your username. Great. So let's go here, vi client.js, and here we're going to say this. Dude, this is annoying. I'm gonna have to do this. User state dot. Yeah, no problem. No problem. I know there is a delay. Username equals to Camzak. All right, so node client.js. Great. You have control, my friend. You have control. This is it, just so you'll see I am here. So let me just OBS so I can see myself. Here I am. Go, Camzak.
Wow, dude, that was
awesome.
fast. That was like half a second. It got the signal in like half a second.
Yeah.
Well, look at that. That's even less than half a second. That's like what, 300 milliseconds.
All right.
Damn.
All right. We got the forward thing. Thank you. Look at that. All right, just so you'll see I'm here. Come on, do another one. I'm hanging here.
The power of internet.
I'm just standing here waiting for someone to activate this.
Dude, dude, can I go next? I'm curious. How long does it take? I'm just really
dude,
curious.
it's instant.
Dude, yeah, like that. How can it be so fast?
Write something in the chat.
Me?
Yeah, you. Write something in the chat so I can see your username. Okay, so it's Steven Su.
Yeah, I just want to see how fast it is. Like, cause it feels like instant, man.
It's
like,
instant.
It was like it's less than 500 milliseconds. It's crazy.
Yeah, it's instant.
That's crazy.
So all right, so let's put you here, and then user state dot username equals to Steven's Zoo. Yeah. And what we're going to do here is another if user state dot user state dot username equals to Steven's Zoo. We are going to say console.log. Are you talking to me though? Right. Okay. So then here, and then node, and great. So let's go, and you are live. Go. Oh, you broke it.
You had a bug, man. You wrote a bug for me. Damn it, fix the bug. Fix the bug.
Oh, this is so typical. Stevens broke the machine. Dude, this is so typical. What is going on? Just a second. So this one.
You're just trashing my reputation now. You totally did that on purpose.
Dude, you are incorrigible. So here, this is user state. This is so like this is. Oh my goodness.
Fuck! Now I have to wait 30 seconds.
No, go. Do that.
All right. All right. Hey, hold the car. Hold the car. Oh shit! That's definitely like something around 500 milliseconds.
No, it's instant.
Yeah. Well, half a second is considered instant. Yeah, I can't do it for another. All right, one more time.
Are you talking to me though?
Yeah, that's almost instant. That's almost instant.
All right, cool.
It's like half a second.
So so that is awesome. I don't know, guys, if you are like appreciating what we have here. We have a remote control car being controlled by the chat. All right. Yes, we have whitelisting of users and everything, which, you know, you're all our assholes. So I'm protecting myself from your assholeness. But basically what we have here is a working Twitch bot that is controlling a remote control car. So that is awesome. So what I want to do now is I want to build the backwards function. So let's go ahead.
One more question.
Yeah, sure.
One more question before you go. Is there anything special about this car, like this RC car?
Nothing.
And this remote control. When you bought it, is there anything unique about it, or it just has like regular remote control?
Dude, it's literally, and I can show that to you. Let me show you. I literally just like ordered off Amazon the first or second one I saw. You know, just there is no smartness in it. This one. That's it. Just ordered one, and it came with you see it's like this remote control.
Shit, $27.99.
You see it's this remote control.
Yeah.
And I basically took the remote control apart and soldered the Raspberry Pi and wrote some Node code.
How did you know how to work with the remote control? I mean, I imagine it didn't come with any menu or anything.
What, dude? It's just a simple circuit.
All right.
It's like electrical circuit. What I needed help with. So yeah, drones are next, 100%. Now that we know how that works, nodes are next. Drones are next. So let's tweet this out. I'm like so excited about this. Let's tweet this out. If you guys can help me with this, I would love it. But I'm gonna tweet this out. I'm like so excited. I can like burst. So let's do that.
What do you want us to tweet? Like,
tweet whatever you want. Just the channel URL and tweet what you want. All right. So. I don't know, something Raspberry Pi and Node and I don't know, JavaScript. All right, so what we're going to do now is build the Kamzak, you have twice as many as I do? What do you mean? That's all right. You can share on Reddit or whatever you want. You don't have to, but I'm just excited. All right. So now what we're going to do is we're going to build the backwards. Now, because we're going to build the backwards, I don't know, by the way, how many followers I have. Probably around 1,000 or 1,200 or something like that. All right, so let's go ahead and connect what we need. All right, so we need this. And this thing is called an optocoupler. You see this here?
Octo what?
Optocoupler.
Octocoupler. What does it do?
Just a steady current.
Okay.
Now we're going to put this here. If you can't hear me, let me know. I'm gonna change the microphone a bit. All right, so I'm old and I can't see the direction here. Okay, got it.
Damn.
Okay, so now you see this from the bottom right, from the bottom left, I'm sorry, I am going to ground.
So people in the chat room are saying they cannot hear.
Oh yeah, so so I explained it before. So this microphone is extremely sensitive. Well, I'm not sure that's the right word, but it's basically I have to be here for you to hear me. Otherwise, you don't, and that's what gives it the quality. But unfortunately, it works against me here. So all right. So now the optocoupler is connected to ground. The next thing we are going to do is we are going to need to connect another couple of these to the remote control, the part that goes backwards. So let's go and check what is the part that's going backwards. So I'm looking at the remote control, right? This is the remote control, right? And what I do, just so you'll see, I'm shortening the circuit. And for this to really work, I need the car to be...
One dumb question when
So
you
you see
say
the
you're
car behind me?
shortening this. Yeah.
All right, so I'm shortening the circuit, and let's hope it's not gonna fall off the shit. What's that for? Oh man, you're such assholes. Oh man, you're just like oh shit. You literally just like gave me a heart attack. All right, I'm going to put this here. That was awesome. All right, so now I'm going to shorten the wires here. And you see?
What do you mean shorten the wire? What does
like
that mean?
Close that circuit. You see, you have here and here, right?
Oh, like make it shorter?
Yeah, no, not shorter. Shorten means like close the circuit. Close the electrical circuit.
Close the electric circuit. Okay.
Right? So what I'm going to do now is I am going to solder a couple of these so we can connect the backwards. All right, so I don't know what's this delay. Who told you that delay? Is that Nightbot? Like what is the where is the delay coming from? All right, so let me solder this for just 1 second.
This is absolutely nuts. This is nuts, man.
Okay, so we have those wires connected. And yeah, there is a stream delay, but and I don't know where this delay is coming from. If someone can tell me, like on OBS, where is this coming from, I would love to know. but there is nothing on my side that is supposed to do that.
Now I can't really hear you. I can't even hear you now.
Well, now I'm not talking.
Oh, that's why.
All right. And the next one we need is basically to connect the positive of the optocoupler to the pin on the Raspberry Pi, right? So let's look at the Raspberry Pi pin out. Raspberry Pi pin out. Okay, and then this is the Raspberry Pi 2. So I already had a problem with that, which is not the correct one. This is the correct one. So you see, this is the pins that I have on the Raspberry Pi. And you see, I already have one connected to pin number 2, I think. So let's look at client.js. And no, pin number 3. Oh, so no, this is not correct, actually. This one. Yeah, that's the one. Okay, so pin number 2. Well, this is weird. GPIO setup, right number 3. This is weird because it's supposed to be pin number 2 that I'm connected to, but I'm actually activating pin number 3. So yeah, this is a 3 volt. So that's not pin number 3. This is a 3 volt. So something here is wrong. This is the number. This is the Raspberry Pi 2 again. I need the Raspberry Pi 3, man. Come on, GPIO. There it is. That's not what I want. I don't want to log in. I don't want to log in.
Just sign in with Facebook.
What is going on? Okay, there it is. Shit. Pin out. Let's see. Pin out XYZ. Okay, so yeah, this is 3, but this is a 3 volt. Right, wiring pin 9. So no, that's not true. That's a 3 volt one. Because you see, if I connect it, it immediately gives it power. So that's not true. That's a 3 volt one. Or actually, whether it might be off. So this is ground, and that's cool. And no, it's like the pin number 3. I had that somewhere, and I don't see it anymore. Raspberry Pi 3 pin out. Raspberry Pi. Yeah, everything says that this is pin number 3 and this is pin number 2 and this is pin number 3, but that's not correct. That is 100% not correct because I am activating pin number 3, and if I change it here, it's giving it power, so that means that's a 3 volt. Okay, this is good. This is good, I think. So this is a 3 volt. So yeah, this says it's a 5, but it's not 5. This is a 3 volt. And this is a 5 volt. Well, this is weird. Okay, so GPIO 2 and GPIO 3. No, man. 100% not correct. So I am on GPIO 3. Wow, this is so weird. I literally had that thing. So 3 volt, GPIO 2, GPIO 3. No, something is wrong. So this is GPIO 3, and we have a forward. Okay, so where is our pinout? So the thing that kind of shows me this is wrong is that it tells me this is a GPIO number two, and from my code I am clearly activating GPIO number 3. And that is why, so RaspberryPi 3 model B pinout. Okay, so you see this is this 2. It tells me this is GPIO 2, and then so this is 5. So this is 3 and this is 5. Okay. Great. So this is 5. This is supposed to be a 3 volt, but I guess this is 5. So let us check that. So vi app.js here. So let's go here and change 3 to a 5. Okay. And what's supposed to happen now? So let's connect 1. Okay. So then here, let's do sudo node app.js. All right, this went backwards. Great. So now let's go to our client.js. Wait, I need to verify that it went backwards. So let's do that. And node. Yeah, it went backwards. By the way, it's much faster backwards than forward. Kamzak, the chat client is not yet connected. So let's do that. So vi client.js, and let's do this. So pin number. So let's do var pin number. This VI thing is starting to annoy me. Pin number equals to 3. And let's do, what did I say? So pin number 5. All right, so vi client.js. And then here we are going to do pin number 5. So who shared to Reddit? Who's going to bring the most users here now to see what we are going with here? And then here,
I can share it to Reddit.
so if message equals to forward, oh, actually, let's do backwards. Then pin number equals to 5. Right, so then here, we actually need to ignore, we need to ignore whether it's, all right, anyway, so let's do this. And then and then here we're going to pass the pin number. And here we are going to do or message equals to backward. Here, and then we are going to pass the pin number. So this is going to be pin number, and this is going to be pin number. Here, great. And then here we are going to pass an anonymous function.
Okay, I posted to Reddit.
And then off with pin number, like so. And here, pin number. And also here, pin number. All right, so let's do that. And let's do node app.js. You guys that have permission know what to do now.
So we just do backward?
Yeah, try backwards or forward.
No.
Try forward. Oh.
No.
I'm sorry. I did not activate the client. I activated something else, node client.js. I'm sorry about that, guys. I activated the wrong file. All right, Stevens, go ahead, do that. All right.
Oh, it works.
Backward works. Do forward.
Wow.
All right, let me do something here real quick.
What? I have a really important question, but whenever you catch a
Yeah,
break,
give me
I
a
really
second.
wanna ask it.
Give me a second.
Okay. Full back. Full back.
Okay, here we are.
What is that? That's her dog. Oh, that's the car. All right, let me give it a try. Oh, look at that! God damn.
Come on! Don't
Oh shit! Don't break the car!
don't break the
Don't break-
closet.
Don't break the car! Oh fuck, I'm blocked for the next 30 seconds. I think backward is malfunctioning.
Let's see.
Maybe there's a typo.
So this went forward.
Did anybody get backward working?
So backwards.
I think backward is also going forward.
No, forward works and backward doesn't. Right, backward.
I'm blocked. I think backward I hear the sound, but it's going forward. So it seems like the pane got messed up. You see that? Like the bump no hump. Okay, I can't even. In the bump no hump done. Just type backward, and then I can hear the noise. Okay, I'm gonna type backward now.
Go.
You ready?
Yeah.
Okay.
Okay.
Is
Yeah.
that backward? Or
Yeah. It
forward?
went forward.
It went forward. Yeah.
Yeah.
The camera went black, so I think people in the chat can't really see it.
Yeah. So let me put the camera back.
Oh.
Focus. Hello. Okay. So let's stop this. And let's do something here. Running the car and sudo node app.js. So this is definitely going backwards. 100%.
Okay, so the problem is in the code.
So the problem is in the client code.
Yeah.
So let's go to the client here. And pin and if message. Oh, got it.
Yeah, you got it.
Backward.
There we go.
So let's do this. Great. And then node node client.js. Go, guys. This
Now
is
it's going backward.
this is
Now
backwards.
Yeah, I type backward. Okay, so it's working. It's working. Hey, do you mind explaining a little bit? What do you mean when the different ping, like when they're different number? Like what does
The
that
car just had a heart attack.
What's going on? All right.
All right, cool. All right, awesome.
You know the delay in the chat.
The delay in the
really
stream.
sucks.
The
Yeah, in
delay,
the stream, that's
yeah, the delay in the stream sucks.
But people in the chat, they can't see it move instantly. They see it 10 seconds later.
There is literally zero delay. Zero.
I know, but they cannot see it. You know, when they type forward or backward, they can't see it on their screen that the car is moving. You know what I mean? Like when they type it, for example, it's moving on you know, in your room, but by the time they see it, it's 10 seconds later.
All right, I have an idea.
What?
All right, so let's put the car here. You guys can play with it. It's over there, but it's on its roof. So so you hear that?
Yeah, like for me, I can hear it instantly, but for them, because the stream is delayed by 10 seconds, kind of sucks for everybody else.
Yeah. So the question is, how can we solve that?
Unless there's an instant that's a tricky problem. Unless you skip Twitch and deliver the images instantly.
No, so what I'm thinking is delay the car by 10 seconds.
Ah, okay.
So, but we need something. So I will do something here to see. So I will start a timer, a stopwatch, okay? And when you guys see it, just type the seconds you see, and then I will calculate. So just look at the left side here and tell me what is the seconds you see. And I will try and calculate what is the delay. Because I think it's even more than 10 seconds. I think it's like 20 seconds.
10, 5.
20. All right, it's 10 seconds actually. Oh, for Chemsec, it's more. So it's around 15 seconds. I can't really do anything about that.
No, I can just tell you how long is the delay because I have instant access to your voice, and then I have the Twitch open up on my browser.
So what do you see on Twitch now?
I'm seeing 53, 54, 55, 56, 57, 58, 59.
Okay, so it's 15 seconds.
So it's 10 seconds. No, yeah, it's 10.
10 seconds. Okay, so let's do that.
It's 10.
And let's do the client.js here. And then here, we are going to set timeout and function here. And we are going to put on with pin number of 10,000. Okay.
No, but like, how does that work? How does that help?
Oh, that. So
That
you
doesn't
will
help.
write it, but it will only move 10 seconds later.
Yeah, exactly. So they will still see it. They'll wait like 20 seconds in this case.
No. So let's go right forward now. You, Stevens. Okay. So now 10 seconds and the car will move forward. So you will see it on the stream. Tell me when you see it on the stream moving.
I see it now.
But you see it on the stream?
Not yet. No, that's what I'm saying. It's gonna be 20 seconds. Yeah. I think I just saw it on the stream. So delaying is. I don't think that's a solution because no matter what, you can't get away with this 10-second delay. No matter what, as the sender, like I'm the sender, right? Like if I'm the guy in the chat room, I'm sending at 10 seconds. You get it. You wait 10 seconds.
Oh, then you
moves,
see
the stream
20 seconds
comes,
later. Yeah.
Yeah. You're delaying it. That's what I'm saying.
Yeah.
This doesn't help because there's no way to get away with this.
Yeah, I need something like predictive. I need to predict when you say forward and then.
No, that's impossible. The problem is the stream.
Let's see.
Is
Twitch.
delayed when it happens on your camera and when it get delivered to Twitch. There's no way for you to predict.
I know there isn't. I'm just kidding.
Crazy.
All interaction with chat, focus on your stream. We encourage you to try reduce delay option. Viewers will see your reaction to their messages sooner, but some of them, especially those with poor connections, will more likely do that. All right.
Do it.
All right. So let's do that.
Raspberry Pi stream control using neural network to avoid delay. It's crazy. This is nuts.
Wheels down. All right, so let's do wheels down. And yeah, let me just remove that that delay because that delay is stupid.
Yeah, it adds 10 more seconds.
So let's delay that. What I can do though is
why are you putting the Twitch?
No, that's not what I wanted. No, that's not what I wanted. On and pin number. Right. So client.js. All right. So there you go. Play with it.
Wait, what did you do? What's different?
It's like I just removed the delay. Ah! It's stuck.
Oh man, it works flawlessly. Flawless, man.
Ah!
It flipped.
That's it. The car is dead.
You killed the car. Kamzak totally killed the car.
All right. So what?
It's still moving on the floor. Dude, go save the car, man. Save the car. Okay, yeah, you did save the car. Yeah, put it on its back. Yeah.
You guys are having way too much fun. You guys are having way too much.
Dude, let Rodrigo try this. Hey, Rodrigo. Is that Rodrigo?
All right, go.
All right. Show it to Rodrigo.
Oh, you know what though? You can actually do you see the so do you see, oh, one thing for the people watching the chat to understand how fast this is, you can see your message on the left side here coming in, and then you can see the car on the stream. So you can actually see how long it takes. So this is a much better way to understand how fast this is. Check it out.
This is so fast. It's literally 500 milliseconds, man. It's less than a second. I'm pretty sure this is less than a second.
Go forward.
No, I'm blocked.
Just do something else. Write something else and then write forward.
Yeah.
All right. That is cool.
Hey, can you explain a little bit the different pings? I'm just very curious about that. Like,
all right. So
what does that mean? Like different number of pings?
Ow. Shit. Ow. Shit, I banged my head against the table, the desk.
It's okay.
All right.
It's
so
okay.
let me try to explain this, okay?
Please do. Enlighten us. I mean, enlighten me if everybody else understood, but I have no idea how this works.
Okay, so let's try and explain this in plain English, okay? So the car, like, ignore the car right now because the car is remote controlled, right?
Yeah.
All we do is control the remote control. Make sense?
Yes.
All right. So I'm not actually controlling the car. There is nothing on the car, right? There is nothing. The car is stock as it came from Amazon. I just put batteries in. That's it.
Right.
Okay, cool. So the car has a button, right? So what does a button look like in electric sketching? It looks like this, right? So it's basically two dots that are unconnected.
Okay.
And then when you want to light something, right? So literally when you want to do, when you want to pass a positive current, you need to connect the dots, right? So this is no light. And this is let there be light. All right, so this is no light and then let there be light.
So one is connected and one is disconnected.
Yeah, this is disconnected.
Mm-hmm.
And this is connected.
Okay. That's what a button look like.
Cool.
Okay.
That's a button. Now, when the car is not running, then that is the state of the button, right? That is the state of the button.
Yep.
And then when we do something with the Raspberry Pi, when we say, hey, turn on the GPIO, we basically make the circuit go to that state.
Correct.
So think about it literally as a circle, right? Literally a circle, right? So when the button is off, the circle is broken.
Mm-hmm.
All right? When the button is on, the circle is just back together.
Yeah.
So what you understand now is that this is what happens when, like, I press the button, right? So when I press the button, I basically shorten the circuit. I basically connect the circuit. Shorten means connecting. Right? When I say, hey, I'm going to shorten this, that means I'm connecting this.
Okay.
Right?
Okay.
So what we need to do is we need to basically shorten the circuit. So this is what the basics of what we need to do. We need to shorten the circuit on the remote control.
Mm-hmm.
Because we need to simulate like we are pressing a button, but we're not actually pressing a button.
Okay.
All right. So now on the Raspberry Pi, so let's try to go there now. And this is extremely small, so I'm going to try to, make it as best as I can. these two wires, so the gray wire here and the, I don't know what this is, like purple, right? So you see this gray
Reddish.
here and
Yeah.
purple here. So
Yeah,
they
yeah.
go to this circuit, right?
Okay.
And then this one, where the positive current passes, is connected to the Raspberry Pi pin. And this one is the negative, is connected to the ground. So
the
basically
ground,
what we have here is we have a circuit that is disconnected because there is no current passing in it.
Mm-hmm.
So when I activate the pin on the Raspberry Pi, I basically pass current through the circuit. And because I pass current through the circuit, that activates the something on the other side.
That makes the circuit. So that connects the circuit, basically.
Yeah.
So does it matter which pin do you use? Because I see there are like multiple, like 10 or 20 different pins on the Raspberry.
The pins have multiple functions on the Raspberry Pi. One, there is a 3-volt pin. So the pin next to this one is a 3-volt. That basically means that it's always passing current. You can't turn it off or turn it on.
Okay.
It's always passing current. And then there is 5-volt pins. And there is pins that are digital and pins that are analog. Those are like the pins.
And which ones are you using right now?
I'm using digital pins, which have an input and an output. But all I'm doing with them is passing an output.
So you're not using the 3-volt or the 5-volt?
No. No, if I was,
it will always be
it
on,
will always be on.
Okay, so the ones you use are the digital, not the analog.
No, digital output.
You're using the digital output, so you can control the signal, you know, with code, right? So when you do Node app.js, then you activate that pin. So that pin sends a signal to the circuit, and then the circuit, or to the remote, and then that kind of causes the action on the car.
Yeah.
Oh, awesome. All right, got it.
Okay.
That's very clear. Thanks.
So basically, when and let's do this now. Listen to me through the Skype and not through the Twitch, right?
Yeah.
So now type forward in the chat. So what happened now is a current passed through the number 3 pin, right? And activated the circuit. Now type backwards. Right? So now that went backwards. So that passed the current through the number 5 pin.
So they use different pins? Okay, yeah, they have to, because one pin can only be used with one function.
Yeah.
That's awesome. That is absolutely awesome. It's called, oh shit, dude. One last time.
Yeah.
Don't be mad. One last time. What board is it called again? The whiteboard? What board?
It's a breadboard.
Breadboard. Okay. I'm going to write it down.
All right. So what we're going to do now, and here is the car as well, so you can actually see it. But let's not break anything here. Okay, so this is the car. What I want to do now is... Kamzak, man, you are more than welcome. Matzah board. That's how my daughter calls it, by the way. I don't know if you heard it and that's why you say it, or you just say it. But this is how my daughter calls it. It's so funny that you mention it. Yeah, see you, man. Thank you so much. You're awesome. Thank you, and thank you for last night. It was really awesome. Thank you.
Good night, Kamzak.
Okay, so how many viewers do we have right now on Twitch?
11.
All right, so let's see. I wonder why we only have 11. It's 9:30. Usually that's the highest time. Let's see. I don't know. Anyway, so let's do something else. And what we will do is let's do something else. So let's go to the client.js here. And what we will do is we will say this. I don't know if it's interesting enough, but what I wanted to say is like how many seconds do you want the car to go forward? And how many seconds do I want the car to go backwards? But I don't know if that's interesting enough. So I think at this point we'll just open it up to questions. So people in the chat room, it is 9:25 p.m. We built in a matter of 2 hours a car that is controlled by the Twitch chat. I don't know if you appreciate the magnitude of what we did here, but it's pretty awesome. And we did everything with JavaScript. Again, it just shows you how much JavaScript is really the language that you should know, or at least should learn, because it's literally taking over everything. And you like, we built a bot. We say, hey, connect the bot, do this, do that. So everything is built and neatly tied together. All right, so now it is the time for questions. Oh, and by the way, one thing we can do, Stevens, just so you'll understand, right? So we have this thing. You see this? Looks like ET's eyes.
Yeah.
So that thing, is this going to be doc and open source? Yes. What do you mean? Dude, everything is open source. Everything I do here is open source. So yeah, this is going to be open source. I'm probably going to open source it tomorrow, document it. And Stevens is going to write the blog about it. So special stream, do you have control of the car? Do you want control of the car? All right, so let's do this. So this one, right? Here. So this is my plan, for example, for this one, right? So this one is going to be mounted on this Raspberry Pi.
What's this Raspberry Pi?
Just another Raspberry Pi.
Okay.
And this Raspberry Pi is going on the car.
All right.
Right? Now, the Raspberry Pi goes forward. This tells it, hey, man, I'm about to hit something. Then we'll stop.
This is the infrared? This is the infrared detector or something?
It's ultra, I don't know what it's like, what's the name, ultrasonic or whatever, but it's basically a proximity sensor, so you can see how close you are to something. So special stream, let's open you up for the control. So I am taking control away from Camzak because he's not here. Special stream. Oh, is it special Steam? Special stream. All right, so node client.js. Go ahead, man. Let me open the car. The car is done. So go ahead, right forward or backwards. All capital letters. Oh, did I? Where did I typo? Okay, got it. Let's do that. I'm sorry. So let's do that. Vi client.js. I'm sorry. So Oh, yeah. Got it. Okay. Here. I'm sorry about that. I didn't mean any harm. All right. So node client.js. All right. Go ahead, man. Forward or backwards. And if the chatbot tells you did something wrong, just write gibberish and then write forward or backwards. And you can see the car wheel here. All right. Haha, there it is. There it is. It is a bummer. The chat delay is such a bummer.
Yes.
The chat delay
should
is such a bummer.
You should upgrade it to the beta version. Maybe it'll fix it. At least reduce it.
Yeah, I'm gonna try. I'm gonna try. I don't even know how to do it. Channel beta. There it is. Reduce stream delay. Okay, what now? Save changes. All right, cool. So special stream, did you see that? Did you see your the car moving on your command? DZYR TV. Yes, you can. Let me open you up for that. DZYR TV. Yes, you can. It's $1,000 per turn. And yes, you can. Let me see that. So, Stevens, I am closing you. And we need to be smarter about this, but for now, that's fine. Client.js here. So let's close this and node client.js. Dizzier TV. Yeah, I know, man. This was a hack of a second. I know. You're telling me I need to do it in a set. I know I do. All right, Dizzier TV. You can do that. All you need to do is write forward or backward. And I don't even have control of the car. All right, let me show you that. All right, let me. There you go. Here are my hands, by the way. One is holding the camera and one is holding this.
He's saying no way.
All right, go. Here's my hands and one is holding the camera. And here are my legs. No background, backward. Ah!
What?
Yeah, it's pretty cool.
Fuck my life.
All right, I'm bored now. Come on, guys. Do something. All right, nobody's moving. Everybody's like, this is not chess. This is just a remote control car.
I'm not sober enough for this. Are you drunk? DZR TV, are you drunk?
Thank you for the follow, by the way. No, you're not supposed to see it in real time, but that's not about the car. That's about the way Twitch stream works. And again, the way to kind of understand how fast it happens is you can see the chat, your chat coming in here, and then you see the car. So then you kind of understand how fast it happened, even though it's not real time to the chat. So try that out and then look at how fast that happens versus how fast the car moved. And then you'll understand how fast this happens. So let me show you that. All right, so now do that and watch really the left bottom side of my screen and see when that happens. Not testing. Oh, got it. Okay. So you probably have about 15 seconds of delay, unfortunately. I just enabled beta on my stream channel, but it would probably take 24 hours for them to enable that or something like that. All right. So
it's really fast. It's really
so
fast.
did you see that? It's like it's in regards, I mean, in relation, not in regards or in relation, I mean, comparing to the time where things come in, it's instant. But unfortunately, the stream is really slow. And again, I'm gonna try maybe it's settings in my OBS, maybe it's something with Twitch. I don't know. But you can see the car wheel here. All right, and you can actually see this is the thing that's controlling it. So all this code, by the way, that you see running here is not running on my computer. The code is running on this computer here. And this is, you see, this is connected via USB just to recharge, but it's Wi-Fi and everything is connected to the Twitch from this thing. I can literally turn my computer off and it will still work with the Twitch chat. This is a recording from the future, 100%. Yeah, so yeah, this is really cool. And you can see again, all of this is running on here, right? So everything is running on here. This is all connected, and it's connected to the remote control of the car. And everything is being controlled by the Raspberry Pi. Which is
So Avi, question here.
Yeah.
So the breadboard, does it matter where? I think it matters where you plug it in the breadboard, right?
Yes, of course it matters where you plug it in on the breadboard. And again, let me show you a breadboard here.
How do you know that? Is there like some sort of instructions?
So,
how like
you
each
see
pair of?
You see this breadboard?
Yeah.
Okay, great. So these are connected together.
Okay.
All right. And then these are connected together, but
Okay.
these are not connected to these. All right. So here,
All right.
this line is a separator.
Okay.
Okay.
So when you want to shorten a circuit, what do? You connect two lines?
So because this circuit is built on 4 lines, right? Because you need the optocoupler in the middle here, right? So the optocoupler positive goes to the Raspberry Pi digital output, and then the ground goes to the Raspberry Pi ground, and then the other side basically goes to the controller to shorten the circuit.
So for one circuit to work, let's take an example, the forward example. How many wires do you need on it to make the whole circulation works?
So
the whole loop.
You're right. So just for one command, you need. So if you want a Raspberry, please let me send you an Amazon link and get it from that link. All right. So this is what you need. You need 1, 2, 3, 4 wires and 5 for the ground.
You need 5 wires. So you need 5 wires to get one.
So you need 5 for the first one, and you need 4 for the rest of them.
What's the extra one for?
So you just need 1 for the ground, and the rest just go to that wire. So 1 is you need from the ground on the optocoupler to the one on the all right, so let me just 1 second. I'm going to send you an Amazon link of the Raspberry Pi that I got. Again, just so you'll understand, this is not a come on, what did I want to say?
Commercial.
Yeah, this is not like a referral link. I'm just linking you to the product. All right, so there it is. So this is the Raspberry Pi. As you can see, there is no referral link or anything like that. It's all pure recommendation. Okay, so, but by the way, just so you'll understand though, just a second. I need to disconnect the soldering iron. So just a sec. All right. So unfortunately, I am stupid. And because I am stupid, I actually turned off my computer while I was disconnecting my my soldering iron. And that's what happens in general when you're not that smart. Okay. So let me dial Stevens back in. Otherwise, he's going to be insulted. So let me dial him back in. Okay, and let me open up Twitch again.
The person whom you're trying to reach is currently.
Okay, so I'm trying to dial Stevens back in.
What happened?
I turned off my computer.
Oh, you did. That's nice.
Yeah, because I was reaching for the like extension cord, you know, under the desk, and that extension cord has like a on-off switch. So I basically when I pulled the wire for the soldering iron, I basically accidentally hit that. So it kind of killed everything.
Got it.
All right, so now let's go and SSH to the Pi again. And I want to show you something interesting, okay?
Can you share your screen with me?
Yeah. So what I want to show you now is I'm connecting the Pi here. And you see as I connect it, everything is wired because the pins are, by default, they are on. And this is kind of what happens with the Pi, because you first need to, by default, the pins are on, and then you need to turn them off. All right, so let's go ahead and SSH to the Pi. And node, all right, so let's export auth equals to cat credentials. And then node client.js. All right, so we are connected again. So can you write forward or something so we can see it?
Can you share your screen so I can see like the...
All right, yeah, I can see it. Great. Yeah, let me share my screen with you. All right. Anyway, I think we were winding down, but you know, just in case. All right. So, yeah, I don't know how many people stayed while my stream went dark. But what we have here again, essentially, is a Raspberry Pi connected to a remote control car. You can see the car here, and controlled by the chat. All right, and we did everything today. Really, nothing was done before. And great. So now here, so who is still here that has control of the car?
I think they're probably all gone.
Yeah, so let's give you control back, and we're gonna refactor this. All right, so type forward. Yeah, I removed you. All right, cool. So there it is. And type backwards. All right, cool. So it's working. Awesome. So,
Rudy, did you wanted to say something?
yeah,
earlier?
I think
You
this
wanted
is
to
the
show
time
something?
to open it up to questions. It's like 9:45.
Yeah.
So it's really
I'm
the
just
time.
curious, like, what can we? Is there any reading material you would recommend? Like, let's say if anybody in the chat room or me, like, we want to read more about how the breadboard works, because I think that's a bit complex. Like, how to get. Like, I know you already know this stuff, right? But I think we probably need to read up on
I
our
think it's
own.
just basic electronics. I think a lot of the basic Arduino, a lot of the basic Arduino tutorials will show you that, because they really focus on like turning on a LED and reading the input from here and putting the output there, and they kind of show you that.
Okay.
And there is a
I'll have to
YouTube channel that I can't remember. There is this guy. Let me show you. There's this older guy. I can't remember the name. Yeah, there it is. This one, Paul McWhorter. This guy. So check out that guy. He has a very good
Hello,
channel.
guys. I am Paul
About like Arduino, and he explained things very slowly. For me, it's painful watching. But I think, a lot of his tutorials touch the very basics of like how you turn on a circuit. And he has, kind of sketches and presentations and so on. So that's a very good content to go and read up on.
So he has several ones, like how ultimate Raspberry Pi project. Is that the one?
No,
you're
just
talking
go
about?
to the just go from the start. He has an Arduino series.
Oh, Arduino.
Yeah,
Got
just
it,
start
got
with that. That would be the best. All right. So thank you everybody for being here. We are going to call it a night. It was amazing today. And yeah, thank you for being here. Thank you for the people that control the car and participated. This was fun. And we are going to
Thank you,
continue
Ari.
this tomorrow. So tomorrow we're going to make a right turn and a left turn. And we are going to do a little bit of maybe like obstacle avoidance. So we'll see. It will be fun. And we will see you tomorrow. Bye.
Bye.